Okay, hi everyone. This video will go through the Term 3 WA2 revision paper 1. So please make sure you have completed this before watching this video. Okay, so let's look at the questions in this revision paper. Let's start with question 1. Given that k equals to log base 9x, express log base 9, this expression here in terms of k. So if I analyze, right, what we need to do is to take this expression, manipulate it such that I can turn all these different things over here in terms of k. So let's start by the expression first here. Log base 9, and I have 1 over 3 times root x. Okay. Immediately straight away over here, you can see that I have a fraction. We usually will want to get rid of fractions to make it easier to manipulate the equation. And based on the properties of logarithm, we can see that this can be turned into log base 9, 1 minus away log base 9, 3 root x. Okay, I put a bracket so that it's clear that this 3 root x belongs to this log function here. Okay, then afterwards, if you recall, anything which regardless of base, as long as this is a 1, this will become 0. Okay, and over here I have this is 3 times root x, and I can apply another law of logarithm. But take note, if I'm applying my law of logarithm, right, this thing here is a negative sign. I'm not doing anything to it. I'm changing this log base 9 into log base 9 3 plus log base 9 root x. So very common mistake is that a lot of students will forget to put this bracket, which will cause you to make a careless mistake, because this when you apply this product law over here, there is we are not changing anything to this minus sign over here. So therefore it is important to put this bracket to be clear. Okay, then after that, once I've done so, then this will become simply minus negative log base 9 3 plus not plus anymore, it will become minus away log base 9 root x. Okay, then after that, moving on from here, we try to simplify this even further. I'm given that k equals to log base 9x, and I'll try to obtain that from this expression here. And log base 9 3 can actually be seen as, if you are fast, you can see the answer straight away, but let's say you are not sure. What you want to do is to turn this 3 as a power of 9. So we know that log base 9, 3 can be written as 9 power half. Okay, and we know that the half means square root, and this is minus away log base 9. This square root here can be turned into a power as well. This is x power half. Okay, then after that, I can bring down my power, negative half log base 9 9 minus away half log base 9x, and I can simplify this even further. I know that log base 9 9 is simply 1. So my final answer to this question is simply my negative half, and I know that log base 9x is equal to k. So therefore, this is simply negative half minus away half k. Okay, and I can simplify this further. Factorize out the half, I'll get negative half 1 plus k. Yep, and this is the solution to question 1. Okay. Alright, so let's move on to question 2. For question 2, I'm supposed to solve an equation. When the question says solve, essentially what it means is to find the value of x that will satisfy this equation over here. So what I can do is that I see that I have a unknown power in this equation, and I can use what I will do is that I'll take logarithms on both sides. Because by using the properties of logarithm, we can easily bring unknown powers down. So what I'll do is that first step, I take log on both sides. This will be log, I take log, the standard log base 10, so I can just write it as LG, log 5, holding power x plus 1, equals to log 6. Next step, I can bring down my unknown power. This will become x plus 1 log 5. Okay, please note that you must put a bracket here. If you miss out putting a bracket, you may get confused and think it's x plus 1 log 5, which will cause you to get the whole equation wrong. It's because by power law, anything in this power over here, you can bring it down. So it's the entire power multiplied to this log base 5, log 5, okay, equals to log 6. Therefore, x plus 1, I divide both sides by log 5, is simply log 6 divided by log 5. Okay, then final step, x is simply equals to log 6 over log 5 minus 1, and you can use your calculator to key in your final answer, which is 0.113 in 3SF. Okay, so this is the solution to question 2a. Alright, so let's look at question 2b now. By using an appropriate substitution, solve the equation 25 power x minus 2 times 5 power x minus 3. So as what you have learned before as well, usually in substitution we usually let u equals to certain number power x. Okay, so over here you can see that I have a 5x over here and I have a 25x over here. What I want to do is to extract out a common similarity such that I can use substitution to replace these common terms from this equation. So we can observe that 25 power x, okay, let me write the equation down first, minus 2 times 5 power x equals to 3. 25 power x can be rewritten as 5 square, the whole thing power x, minus 2 times 5 power x equals to 3. And I can turn this into essentially 5x, the whole thing square. You know, by your laws of indices, it's actually, it means the same thing. Minus away 2 times 5 power x equals to 3. Then now I can use substitution. I can simply let u equals to 5 power x. Okay, then I'll have u square minus away 2u. Then I shift this 3, I subtract 3 from both sides of the equation. Minus 3 equals to 0. Then from here I have a quadratic equation now. My next step is simply factorizing it to solve your quadratic equation. U minus 3 times u plus 1 equals to 0. Therefore, u equals to 3 or u equals to negative 1. Then we will have two possible answers. I will have either 5x equals to 3 or 5x equals to negative 1. And you must remember that whenever I have an exponential function, you recall the graph of exponential, it is always positive. And since this value here is a negative, we have to reject this solution. Okay, we will reject this because 5x is always strictly positive. Okay, so what's left is to consider 5 power x equals to 3. How to solve this is similar to part A. I have an unknown power, so what I'll do is to take log on both sides. Log 5 power x equals to log 3. Bring down the unknown power. Log x log 5 equals to log 3. Therefore, x is simply log 3 over log 5. Okay, and my final answer, you key this into your calculator to 3SF, it should be 0.683 in 3SF. Okay, so this is the solution to question 2b. Alright. Okay, so now let's look at question 3 now. Question 3 is the coordinate geometry question. The diagram shows the triangle ABC, and we know that the vertices are given in the question, so what I'll do is to label them to be clear in the diagram. This is 7, 9. B is negative 1, 3, and C is 5, negative 5. Okay, so show that part 1, show that this angle ABC is a right angled triangle. So very simply, for this to be right angle, we know that the gradient of line AB, and when I multiply it to the gradient of line BC, if they are perpendicular, they should be, the value of the multiplication of these two gradients should be equals to negative 1. So what we can do is that we can double check. I will check by taking gradient of let's say line AB, okay, then times gradient of line BC. Then we verify what is the value of this product. If it is equal to negative 1, you can confirm that this angle is a right angle. Okay, so let's look at gradient of line AB. We take y2 minus y1, 9 minus 3 over 7 minus negative 1, which is 7 plus 1, times gradient of line BC, y2 minus y1, so negative 5 minus 3 over 5 minus negative 1, which is plus 1. And I simplify this further, I will have, in this case, 6 over 8, 6 over 8 times, this is negative 8 over 6. And you notice this is equal to negative 1. Therefore, we can make the conclusion that, therefore, angle ABC is equal to 90 degrees. Okay, and I've shown what the question wants me to do, wants me to show. Alright, so this is for question 3 part 1. Let's look at question 3 part 2 now. Okay, M is a point on AB such that the perpendicular bisector, such that MQ is the perpendicular bisector of AB. MQ cuts AC at point P, where P, this point is given by 6, 2, so let me write that down. This point here is 6, 2, and point Q lies on the x-axis. Find the coordinates of point M. So what I can do is that I know that since M is the MQ is the perpendicular bisector of AB, it means that this point M here, it must be the midpoint of AB. Cause meaning of perpendicular bisector means that a line that cuts AB exactly in half at a right angle. So to find the coordinate of M, we can use our midpoint formula. So therefore, I know that simply M is equal to, I take the coordinates of A and B, which is 7, 9, and negative 1, 3. So coordinates of point M is simply 7. Remember, midpoint, to find midpoint, it is you are adding the coordinates and then dividing by 2 to find the average. It is not minus. Okay, so we need to remember this very clearly. I add the x coordinates together. The whole thing divided by 2. Okay, 9 plus 3 divided by 2. Then after that, I simply can calculate that the midpoint in this case is 6 divided by 2 is 3, 6. Yep, so this is the coordinates of point M. Next part, okay, find the coordinates of Q. So if I look at the diagram over here, to find the coordinates of point Q, I simply need to find the equation of line MQ, then find the x-intercept, which is when y is equal to 0. So always remember, to find the equation of any straight line, you just need one point and one gradient. I have the point M. How to find gradient of the line MQ? Okay, so if you observe the diagram over here, they say that MQ is the perpendicular bisector over here, and angle ABC is perpendicular as well. So therefore, we can conclude that therefore BC and MQ are parallel lines. Okay, so therefore, since I know that gradient of line BC is over here, negative 8 over 6, or I can simplify to be negative 4 over 3. So let's write them down first. Since gradient of, I use gradient as M, gradient of line BC is equal to negative 4 over 3. Therefore, the gradient of line MQ is also equal to negative 4 over 3. Okay, therefore, equation of line MQ can be found by simply taking a point on M, which is what you found in part 2, 3, 6. So y minus 6 over x minus 3 equals to negative 4 over 3. Okay, therefore I can find that the equation of line MQ is simply y minus 6 equals to negative 4 over 3x plus 4, y equals to negative 4 over 3x plus 10. Okay, so this is the equation of line MQ. Therefore, last part, since I found the equation of line MQ, my last step is to find the x-intercept, which is simply when y equals to 0. So therefore, from here, okay, when y equals to 0, based on the above equation, I know that 4 over 3x is equal to 10. Okay, x is simply equals to 30 divided by 4, which is 15 over 2. Therefore, to answer the question, you're asked to find the coordinates, meaning that you must state the x and y coordinate very carefully. Therefore, Q, the coordinates of Q is is simply 15 over 2, comma 0. Okay, so this is for this question part 3. Okay, next part, find the ratio of MP to PQ. So what we need to do for this part is to find the ratio of MP to PQ. So if I want to look at this diagram over here, MP to PQ, I know that the coordinates of M is simply over here. Okay, let's label the coordinates. I know that M is simply 3, 6. Okay, and Q, we found Q to be 15 over 2, 0. 15 over 2, 0. Okay, I'm asked to find the ratio of MP, this line here, to PQ, this part of the line over here. Okay, and you notice that this is a 1-mark question. There are 2 ways which you can go about doing it. Okay, you can either, since you know that in this case over here, MP to PQ, I think what many of you would probably do is to take the distance, to find the distance of MP, to find the distance of PQ. That is one possible way. So in this case over here, let's say if we want to find distance, MP simply equals to square root using our distance formula. Okay, MP is 6 minus 2, 6 minus 2 square plus minus 2 plus 3 minus 6, the whole thing square. Okay, equals to, in this case, if I use my calculator, 4 square plus 3 square, which will give me 5. Okay, and in this case over here, PQ, the length, is simply, okay, PQ over here is 2 minus 0, 2 minus 0 square plus 15 over 2 minus away 6 square. Okay, minus away 6 square. Okay, and then we will get 2 square plus 15 over 2 minus 6 square. I will get 2.5. Okay, so therefore, in terms of ratio-wise, MP to PQ is equal to 5 to 2.5. And you know, when I write ratio, I shouldn't have any decimals. So this can be simplified to become 2 is to 1. Okay, so this is the solution for question part 4. Okay, and the last one, area of the trapezium BCPM, simply can use your shoelace method to find area of a quadrilateral figure. So we are, in this case over here, we are asked to find area of trapezium BCQM, this region highlighted in blue. So we just need to identify the coordinates and go in the anti-clockwise direction. So let's say I choose to start from negative 1, 3 over here. I go in the anti-clockwise direction to CQM and back. Okay, so by our shoelace method, area of BCPM. Okay, this is simply equals to half. Okay, half times negative 3, negative 1, 3, 5, negative 5, 6, 2, 3, 6, and negative 1, 3. Okay, remember to go in anti-clockwise direction. Then if you recall how to calculate area using our shoelace method, okay, this will be equals to half times negative 1 times negative 5 is 5 plus 10 plus 36 plus 9 minus away, that I go in the other direction in this case. Okay, this will become minus away 15 minus 30 plus 6 minus 6. Okay, Therefore, from here, what I will get would be half times 5 plus 10 minus plus 36 plus 9. It will be 60. 15 minus 30 plus 6 minus 6. This whole expression here is negative 15. Okay, so therefore, this will become plus 15. Therefore, my final answer is simply 75 divided by 2, which will give me 37.5 units square. Okay, this is exact for part 5. Okay. Okay, so the last part, given that ABDC is a parallelogram, so look at the ordering very carefully. ABDC. Find the coordinates of D. So if I look at the diagram again, okay, ABDC. So that means that my point D, it must lie somewhere over here, in this case. Somewhere here, I don't know where is point D. Okay, but I can easily make a guess based on the, since I know that this is a parallelogram, so we know that, let's consider from A, let's make a marking here, I don't know where is point number D, okay, but from A to C, I can see that, over here, A to C, the vertical change, in this case, okay, D should be below B directly. Okay, so over here, wait, the vertical change, right, from A to C, I'm decreasing by from 9 units to negative 5. Okay, so therefore, the vertical change is simply 14 units, whereas the horizontal change is from 7 to 5, is minus away 2 units. So by observation, you can see that from B to D, okay, the vertical change here should be the same as the vertical change from A to C, which in this case should be 14 units. Okay, let me write it clearly, 14 units. And the horizontal change here, the horizontal change in this case should be 2 units. Okay, so therefore, if I make this observation here clearly, I can say that coordinates of point D, okay, observing the coordinates from A to C, for the parallelogram ABDC, okay, it should be, D should be equal to, I take the coordinates of point B, the x coordinate of point B, I minus away 2 units. Okay, so over here, negative 1 minus away 2 units, and the y coordinate is simply 3 minus away 14 units. 3 minus 14 units, and I'll get negative 3 comma negative 11. Okay, so this is my answer for this question part 6. Alright. Okay, so moving on to the last one, question 4, binomial theorem question. By considering the general term in the binomial expansion of this thing over here, explain why are there no odd powers in this expansion. So let's look at the general term formula. Okay, general term formula states that we know that Tn is equal to n choose r, a power n minus r, b power r. Okay, so let's observe this over here and let's state the terms very clearly. From this case, I know that a is equal to 2x, b is equal to, remember the sign over here, this is negative m over x, and the power n is equal to 8. So by using a general term, I can simplify this. So in this case here, for this expansion, the general term is 8 choose r, a is 2x power 8 minus r, and the b is negative m over x, the whole thing power r. Okay, so by using this general term formula, in order to explain why there are no odd powers of x, what I need to do is to simply simplify this expression and combine all the x together, such that I can observe this x, what will be the power over here, and why this expression over here tells me it cannot be an odd number. Okay, so what we want to do is to separate away all the numbers from all the x terms. What I'll get would be 8 choose r, 2 power 8 minus r times x power 8 minus r. Okay, this is what you learn in your laws of indices. This thing can be separated into negative m times x power negative 1, the whole thing power r. Simplify again, 8 choose r, 2 power 8 minus r times x power 8 minus r. Okay, then over here I can separate out this two terms by bringing a power times negative m, the whole thing power r, times x power negative r. Okay, then I simplify everything even further. This will become 8 choose r times 2 power 8 minus r times negative m the whole thing power r, and I combine all the x terms together. This will become x power 8 minus 2r. Okay, then by observation over here, we can see that from here, power of x is equal to 8 minus 2r. And you can make a very simple observation is that I can factorize out the 2. It will be 2 times 4 minus r. So essentially 2 times any number, no matter whether this is odd or even. If I have a 2 over here, this whole expression will always be an even number. Okay, so therefore, I can say that since 2 times 4 minus r is always even, okay, therefore, there are no odd powers of x. In this expansion. Okay, so this is it for question 4a. Okay, so now for question 4b now, you can see that it's built on to question 4 from 4a. Given that the coefficient of x power 6 in this expansion, so now I have x squared plus 1 multiplied to this. Okay, is 768. Find the value of the positive constant m. So by looking at my general term formula again from part 1, I know that the general term Tn is equal to 8 choose r times 2 8 power minus r times negative m power r times x power 8 minus 2r. Okay, so if I observe this expansion over here, okay, in terms of the general term formula, we can see that, let's say if I consider this expansion, x squared plus 1, 2x minus m over x the whole thing power 8 can be rewritten as x squared plus 1 times, then over here, I have a lot of terms inside over here. Using my general term formula, this can be rewritten as dot 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 plus this general term here, 8 choose r times 2 power 8 minus r times negative m power r times x power 8 minus r minus 2r. Okay, plus dot dot dot. Okay, in order to find the coefficient of the x power 6 term, we must therefore observe this over here. When I have x squared, what do I multiply inside here to get the x power 6 term? And by observation, you should be able to tell that I must find the x power 4 term over here that can multiply to x squared to give you an x power 6 term. Similarly, if I have this constant term here 1, I have to find the x power 6 term over here in order to produce a term with x power 6. So therefore, I have two scenarios. Okay, to find x power 6 term over here, this 8 minus 2r here. 8 minus 2r must be equals to, for this x squared term, I must find an x power 4 term. It must be equal to 4. Therefore, 2r equals to 4, r equals to 2. And the next thing, with this constant term 1 over here, I must find the x power 6 term. So therefore, 8 minus 2r, which is the power of x, must be equal to 6. Okay, so therefore 2r equals to 2, r equals to 1. Okay, therefore I can now find the x power 6 term. Okay, so from here we can see that by expansion, okay, x power 6 term is simply the term is simply from the term from expansion, from this expansion, which is 2x minus m over x power 8 is equal to 8 choose 2 times 2 power, now r is equal to 2 power 6 times negative m, the whole thing, power 2 times x. This will become 8 minus 2 times 2, which is 4. Okay, so over here, if I simplify out everything, 8 choose 2 times 2 power 6, I'll have 1792 m square x power 4. Okay, similarly from here, if I simplify further, term from the expansion, 2x minus m over x power 8 is equal to 8 choose 1 times 2 power 7 times negative m times x power 8 minus 2, which is 6. Okay, over here I will have 8 times 2 power 7, which will give me negative 1024 mx power 6. Okay, so therefore from here we can simplify this even further. Okay, let me minimize my workings. Okay, from here you can observe that, therefore, I can see that based on this expansion, x squared plus 1 times 2x minus m over x, the whole thing power 8, this whole thing is equal to x squared plus 1 times plus 1792 m squared x power 4 minus 1024 m x power 6 plus . Okay, and by expansion I know that x squared term multiplied to this thing here will give me x power 6 term, so this will become 1792 m squared x power 6 plus, now this 1 multiplied to this term here will give me minus 1024 mx power 6 plus . And therefore the coefficient of your x power 6 term is simply 1792 m square minus 1024 m x power 6 plus . Okay, last step. Therefore, I know that since I'm given that the coefficient of m is 768, this tells me that, therefore, 1792 m square minus 1024 m is equal to 768. Okay, therefore, I can simplify this expression even further. 1792 m square minus 1024 m minus 768 is equal to 0. Now I have a quadratic equation. I can simplify this quadratic equation. Let's simplify the numbers first to make it easier. Okay, you notice that I can divide the whole thing by 256. You can divide slowly to observe how to simplify your numbers to make it easier. I can simplify this to 7m square minus 4m minus 3 equals to 0. Okay, and therefore, this is just solving a basic quadratic equation from here. Okay, I will have, in this case, by factorization, I'll have 7m plus 3 times m minus 1 equals to 0. Okay, therefore, m is equal to negative 3 over 7, or m equals to 1. And therefore, I'll reject this answer over here because m is a positive constant. Okay, m is a positive constant, so therefore, the solution to this question is that m is equal to 1. Okay, so this is the solution to question 4b, which will really test your understanding of how to apply the general term formula and how to observe patterns when I have expansion of a binomial over here with any other expression. Alright, so this is the end of the revision paper set